Conceptually, we understand work is force into displacement. F dot S. So the potential energy is equal to initial kinetic energy. Now what is that I have to evaluate? It is work done by the heart to pump the blood of 6 meters in water. In water, I am lifting a stone of mass 10 kg. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Previously, I have completed the discussion on the chapter Work, Power, Energy. In my today's session, we will work out numericals from the chapter. And as I told, solving numericals can be very easy only when you people have practiced the sessions. If the theory knowledge is good, concept is hard, getting solutions become very, very easy. So we start solving the numericals on the chapter Work, Power, Energy. The first problem. The problem says a force of 20 Newton. A force of 20 Newton acts on a body and displaces the body through 5 meters. So, a force of 20 Newton is displacing the body through 5 meters. Calculate the work done. We are asked to calculate the work if the displacement is along the direction of the force. In the first case, he says displacement is along the direction of the force. And the second case, the displacement is at 60 degrees to the direction of the force. So given these two conditions, we are asked to calculate the work done. So as usual, before solving the problem, we will collect the relevant data. We will try to understand which is the unknown and formulate an expression between the knowns and the unknowns. So the first thing is we will formulate the data. The data says force of 20 Newton. F, the force acting on the body is 20 Newton, is displacing the body through 5 meters. The displacement caused is 5 meters. Now, in the first case, I will have to calculate the work done if the displacement is along the direction of the force. He says the displacement is along the direction of the force. Force and displacement are in the same direction. Point number 1, please to understand, if force and displacement are in the same direction, then theta becomes equal to 0 degrees. There is no angle between them. They are in the same direction. So theta is equal to 0 degrees. So what is the expression for work, dear students? W is vector F dot vector S. Theory ಓದಿದ್ವಲ್ವಾ? Conceptually we understand work is force into displacement, F dot S, or W equals F S cos theta by expansion of dot product F S cos theta. Here theta is 0. Therefore, cos 0 is 1, your trigonometric table. So this is F into S into 1. So here work done is 100 joule. So in the worst case, the work done by the body is 100 joule. In the second case, he says the body is displaced at an angle of 60 degrees, which means cos 60 is equal to half. So again, W is F, yes, cos theta, 20 into 5 into half. This goes 10 times. In this case, the work done is 50 joule. So in the first case, it is 100 joule. In the second case, work done is 50 joule. Now, the second question. Calculate work done. Again, I have to calculate work done in lifting a stone of mass 10 kg. There is a stone of mass 10 kg and specific gravity 4. Specific gravity 4 at a height of 6 meters in water. In water, I am lifting a stone of mass 10 kg to a height 6 meters in water. I have been asked to calculate the work done. So again, first, when we collect the data, mass is given. Mass is 10 kg. Specific gravity is given to be 4. and height is given to be 6 meters. So specific gravity is 4, mass is 10, height is 6 meters. Now, the stone is at a height 6 meters in water. So first I'll calculate loss of weight in water. So loss of the weight of the stone in water. How much of weight is lost in water? This is equal to weight in air divided by specific gravity. Always remember, by definition, specific gravity is weight in air divided by loss of weight in water. So loss of weight in water will be weight in air divided by specific gravity, which is 10 divided by 4, 2.5 kg weight. So I've calculated loss of weight in water. Therefore, actual weight is 10 minus 2.5. 10 kg was the mass. So weight is 10 minus 2.5, which is 7.5 kg weight. But the unit is kg weight. But force is in Newton. So force is 7.5. I assume this to be 10. So this is 7.5 into 10, which is 75 Newton. So therefore, finally, what is work? Force into displacement. 75, displacement or height is 6. So 75 into 6. So the answer is 450 joule. So the work done to lift the stone in water is 750 joule. Third one, very interesting. Here, the problem says, the heart of a person pumps 3.5 liters of blood. 3.5 liters of blood per minute. Per minute at a pressure of 120 millimeters of mercury. 120 millimeters of mercury. Calculate the power of the heart. Given data, density of mercury is given, volume of the blood is given, then pressure is given, height of the liquid column is given. With this, we are asked to find the power of the heart. Now, the time of pump is 1 minute, which is 60 seconds. So according to the problem, the time of pump is 1 minute, which is 60 seconds. Now basically, power is work by time. So very clearly time is coming into picture, 60 seconds. Now what is that I have to evaluate? It is work done by the heart to pump the blood. Now we'll go back to the same formula. Work done is force into displacement. Force into displacement. Nowhere in the problem directly force is given. But if you analyze, there is something called pressure. There is something called volume. Can I pull out force using pressure or volume? Yes, we know pressure is force per unit area. Alva? Basic definition of pressure is force per unit area. Therefore, this is force is pressure into area. So, I am defining force here as the product of pressure and area. You have one more term here, displacement. Anywhere here am I getting volume? Yes. If you observe, area has the dimensions L square. Displacement has the dimensions L. So this is L cube, which is giving me volume. So this is nothing but pressure into volume. Now, do I know an expression for the pressure exerted by a liquid? You will learn it is rho GH. Pressure exerted by a fluid or a liquid. Here in this case they consider blood. Rho GH, where rho is the density, G acceleration due to gravity, H is the height, into volume. So substituting there, power is work by time, rho GHV divided by time. All these parameters are given as data in the question. That is what I told. Analyze the data. Answer is simple. Simplification is your task. When you simplify, use a calculator, the answer turns out to be 0.93 watts. Each parameter here is given as data. So please do simplify. You will get the answer. The next one. A stone of mass 0.2 kg. There is a stone of mass 0.2 kg which is thrown vertically upwards with a velocity of 25 meters per second. I take a stone. It has mass 0.2 kg. I throw it vertically upwards with a velocity 25 meters per second. I have to calculate the maximum height reached by this stone, and also at what height it will lose 20% of its initial kinetic energy. Now, to begin with here, we clearly see that at a height h, at some height h, the potential energy is equal to initial kinetic energy. So the potential energy is equal to initial kinetic energy. Expression for potential energy, mgh, we have learned, is equal to half m u square. Initial kinetic energy, so initial velocity, half mu square. M gets cancelled. H is u square by 2g. U is 25 square divided by 2 into g is 10. So this is nearly 25 square is 625 divided by 20, which is approximately 32 meters. Now I assume at a height x, the body is losing 20% of its kinetic energy. So here mgx is 20% of initial kinetic energy at some height x. It is losing 20% of its initial kinetic energy. That is mgx is 20 by 100 of the initial kinetic energy. So initial kinetic energy is half mu square. Again, m and m gets cancelled. Simplify, x turns out to be 6.4 meters. So these simplifications, I assume you all to work out. They are very simple. Just you will have to work it out. The next one. A bullet of mass 50 grams strikes a wooden plank. There is a bullet of mass 50 grams striking a wooden plank with a velocity of 200 meters per second and emerges out with a velocity of 50 meters per second. Calculate the work done by the bullet against the resistive force offered by the plank. So there is a bullet of some mass which is moving with a velocity of 200 meters per second. It is striking a wooden plank. Naturally, there is opposition to the motion of the bullet, resistance to the motion of the bullet. Its velocity should decrease and it emerges out with a velocity of 50 meters per second. I have to calculate the work done by the bullet in piercing the plank. I have just mass and velocity of the bullet. How do I calculate work done from this? Very good. We have an established theorem, work energy theorem, which says work done is nothing but change in kinetic energy. So this is half mu square minus half mv square. Initial kinetic energy minus final kinetic energy. Half m is common, u square minus v square. Half into 50, mass is in terms of grams. So into 10 power minus 3, 200 square minus 50 square. Simplify this, the answer will be around 935 joules. So by using work energy theorem, I have calculated the work done. So today's session, we have calculated work done in different forms. Very simple expressions, just simple expressions and calculations. The next session, I will pick up few more problems. Until then, thank you.